Okay. Uh, okay, I'm starting the class. So today we are going to start the new chapter, and it is very important chapter. Today we are going to start the chapter work, energy, power. So this chapter is used everywhere in machines, electricity, sports, daily life, and even exams. Yeah. So when you hear the word work, what comes to your mind? When we hear the word work, we often think like work is like studying is work, or doing homework is work, or lifting things is work. Uh, so we think that these kind of things are work. But today you will learn the that physics has different meaning of work. Sometimes you feel tired, but no work is done in physics. And sometimes work is done even without getting tired. So in physics, there is totally different concept of work, and the work word that we used in our daily life is totally different. So today we are going to study about what work means in terms of physics, in what we learn in physics. So in daily life, we think that studying is work, carrying a bag is work, standing and holding a bag is work. But in physics, studying is not work. Uh, Sometimes it might happen that carrying a bag is not work. So what work is? Work is done only when a force produces displacement. So first thing is in physics, work is done only when a force produces displacement. If there is any displacement by a particular force, then we call it like that this work is done by that particular force. This is work in physics. None other thing is work. Studying is not work in when we talk in physics. Okay, so we can write like that force and displacement when comes along, then we call it work in physics. Suppose you push a wall with full strength for 5 minutes, but if you push a wall for 5 minutes, you will get tired. Yeah, but wall doesn't move. What does mean? You are tired. So is that mean that you have done any work? No. Ball doesn't move since there is no displacement. So there is no work. So in this case, when you move a ball, I can write like example, pushing a wall. There is a wall, and let's say there is a man pushing it. Wall doesn't move. So there is no displacement. There is no displacement. That's why there is no work done. Even if you get tired, doesn't mean that work is done. Now, next, when we talk about scientific definition of work, like a proper definition that goes with the formula and that we are going to study. So that definition is, I'll write it. Work done by a force is equal to the product of the component of force in the direction of displacement and the displacement. So what is work? In when we talk about in scientific terms, work done by a force is equals to the product of components of force in the direction of displacement and the displacement. Basically, if let's suppose there is a block placed on the ground and there is a force, let's say, uh, pulling it in this direction, and there is this let's say mm, when we give this force and there is, let's say, some displacement happen, d displacement, and this block comes forward, then if I am talking about that what is work done by this force, then we cannot simply say that work done is force into displacement. So we can write like F into D. No, we cannot write like this. The component of force in the direction of displacement. So what component, direction of displacement is horizontal. So we have to take the force component that is horizontal. So this direction of force. So I should not write this. Okay. Yeah. So let's say this makes angle theta with the horizontal. So what is the component of force in horizontal? F cos theta. From you can find it from trigonometry, that if this is F and it is right angle triangle and this is theta, then this side is F cos theta. Let's say this is base, so we can write like cos theta is equals to base upon hypotenuse, and hypotenuse is f. So base is equals to f cos theta. So from here this horizontal component comes. So we have to write like work is equals to f cos theta into displacement is d. So we have the formula fd cos theta. So this is work done in scientific terms that I have written here. Work done by a force is equal to the product of the component of force in the direction of displacement and the displacement. So we have to always take the component of the force that is in the displacement direction, not otherwise. So this is what FD cos theta. And we can also write fd cos theta is this, so we can also write f vector dot d vector. This is the dot product, because the dot product also gives us the formula like a vector into dot b vector is equals to ab cos theta. We know this. So from here we can write f vector dot d vector, that work done is the dot product between force and displacement vector. F is the applied force. D is the displacement. And theta is the angle between force and displacement. Angle between force and displacement. Uh, Now we get the formula. So if, let's say, if we have force and displacement in the same direction, for example, if we have displacement and force in the same direction, let's say there is a block and there is a force acting on the block in horizontal direction F, and there is a displacement D. So in this case, the we have to find work. Okay. So in this case, what we can write, formula of work, that work is equals to F D cos theta. F, I have given it as F, and D cos theta. Theta is angle between force and displacement. Now the angle between this force and this displacement is what? Direction of force is this, direction of displacement is this. It means the angle between this is zero. There is no other angle. Both force and displacement are in the same direction. So we will write cos 0 degree. And we know that cos 0 degree value of cos 0 degree is 1. So into 1. So its formula comes to F into D. So if force and displacement is in same direction, or its angle between the force and direction is 0, then we can directly multiply force and displacement. Okay. So instead of writing it like example, this is a case. Okay. So in this case, if force and displacement separated are in same direction. So yeah, you get this when force and displacement are in same direction. Okay, now second case is if force is perpendicular to displacement. So I'm taking the same example. Okay, let take the same example. This there's a block on the ground, and there is some force acting on this, and there is displacement in this direction, and block comes here. Now I want you to find out work done by gravity. Work done by gravity. So I don't now the force is not F. What I am asking is work done by gravity, not F force. So we have to write, first of all we will write formula of work is equals to force F D. Okay, um, let's say I am writing it like F1, some other force, and our formula is FD cos theta. Okay, so what is F? What is force in this case? The case of this question, gravity. So how the gravity like works? It works downwards, and value is mg. So in this case, the value of a force is mg in downward direction. Displacements d. Now see that this mg is in this direction and displacement is in this direction. Cos theta, what is theta? Angle between force and displacement. So our force is mg, our displacement d, and angle between this is 90 degree. So I have to write theta, a value of theta as 90 degree. So cos 90 degree. We know that value of cos 90 is 0 degree. So sorry, 0. Cos 90 degree is 0, and anything multiplied by 0 is 0. So what we can conclude from this is that uh, whenever force, the force that we are talking about, the force that we want to calculate work done with, that force or displacement, whenever they are perpendicular to each other, work done will always come 0 for that case. There is no work done by F1 0. Work done by F1 is this. But work done by mg in same case is 0 because there is no displacement in direction of this force. There is 90 degree between mg and d. And if you guys don't know the value of cos 90 degree or cos 0 degree or any value, you should write the basic, you should remember the basic values of sine angles and cos angles and tan angles. They will come in physics everywhere. So you guys should learn that, like sine 0 degree, sine 30 degree, 60 degree, 45 degree. This you can get it from trigonometry chapter, and anywhere you can get it, and you should learn this so that you can understand this if you are having any problem with the value. So this is the second case when force and displacement are perpendicular to each other. Now we go with next thing, that is unit of work. So what is unit of work? We can see that work is equals to force into displacement. So the unit of force is Newton and unit of displacement is meter. So it comes to Newton meter, and we can also write it as joule. A short is J. So unit of work is joule. And okay, now what is 1 joule? If I say that 1 joule work is done, what does this mean? If anyone say that 1 joule work is done, it means that the work done the work done when a force of 1 Newton moves on object by 1 meter in this direction of force. Okay. 1 joule means the work done when a force of 1 Newton moves an object by 1 meter in the direction of force. So 1 joule means this. You can see from this from formula that if there is 1 Newton force and 1 meter displacement in the direction of force, it means force into displacement. So we can write it as 1 joule. Okay. So what? So joule is a small unit. Joule is a small unit, though it is SI unit, but it is a small unit. In real life, you often see unit as kilowatt hour. You see electricity unit as kilowatt hour. So electricity units as kilowatt hour. We can study it later. It will not come in this chapter as often. We can study it later, but yeah, you should know that joule is very small when we talk about energy. In real life, we use bigger units. Though joule is the SI unit. Newton meter is equals to 1 joule. This thing you should know. Any conversion, anything that happens, you should always try to do all the numericals and all the calculation in SI unit. Then after that, you can convert it according to the need of the question. So now we move forward with the next topic. And our next topic is positive, negative, and zero work. Positive, negative, and zero work. So in these two, I have already taught you the positive work and zero work. You have seen this. I will again teach you about this, but you have already seen this. And negative work. Okay, if I say that there is negative work, it doesn't mean that work is doing some wrong thing or anything wrong happens. No, it only means the sign, only sign, none other thing. It only means that it is somewhat consuming the energy or anything, but nothing negative means any harm is happening or anything like that. Okay, so now I start with the positive work. Okay, positive work happens when force and displacement are in the same direction. Then positive work happens when there is no other thing. it is in the same direction. Like we have seen in the block, like if there is a F force applying on this and displacement is in this direction, then force and displacement are in same direction. Then we say that positive work. When force and displacement are in same direction. We can take this example, or we can say example like pushing a moving car forward, pushing a moving car forward. These are the examples of positive work. Okay, now we can see that force and displacement are in the same direction. We can find out, we already find out the work done when it is in same direction. This we already have done this. So you can see that if it is in same direction, the work done is FD. So similar case is there, same case actually. So when we write work is equals to FD cos theta. F is force, D is displacement, cos theta is angle between force and displacement, and it is 0 in this case. So cos 0, and as I have said earlier, the value of cos 0 degree is 1. So FD into 1. So FD. Oh, work, work. So this is positive work. In when we talk about positive work, we will write. You can see that there is hidden sign here that is positive. So when we say about positive work, it means that force and displacement are in the same direction. And when the work formula will look like this. Now we will talk about negative work. Okay. So in negative work means force is in the opposite to the displacement. The direction of force and direction of displacement is opposite to each other. It is not in same direction, not perpendicular to each other, but it is opposite to each other. Then we say that the work is negative. So when force is opposite to displacement, then we say that the work is negative. The direction of force and direction of displacement will be opposite to each other. um, let's say there is a moving object. This object is moving in this direction, let's say V, and so since it is moving, it will cover some displacement, will cover some distance or displacement, so d distance, but there is a force applying in this direction. Let's say F is applying in this direction. So we can see that body is moving forward, but force is in backward direction. So in this case, the direction of force and direction of displacement is opposite to each other. It is not in the same direction. It is opposite to each other. So direction of displacement is this, and direction of force is this. So it is just opposite to each other. If we draw it in the same line to find out the angle between these, so displacement direction is this and force direction is opposite. Okay, so you can see that angle between distance and displacement and force is 180 degree. It is in a straight line and it is in opposite direction. So when we go to find out that what is work in the case of negative work, so we will write work is equals to F d cos theta. F d is displacement, cos theta is angle between force and displacement, and it is 180 degree. So F and D is normal, and value of cos 180 degree is -1. So now we get minus FD work. So now you can see that this work comes to negative. The sign is negative. So we can say that this work is negative. This is the formula for the negative work when force and displacement are in the opposite direction. If you want to take example life example, so you can see when you apply force. Sorry, when you apply, actually it is a force, but when you apply brake on the moving car, what it will do? It will try to stop the car, and when you apply the brake, car is moving forward for some time, then it will get a stop, but force is applying on it backwards. So the displacement and force direction is opposite to each other. So the real life example is applying brakes to a moving car is example of negative work. That force from that brake is doing negative work on the car. There is one more example of a negative work in real life. There is several example in real life. I am taking some actually. So second example is gravity acting on a ball thrown upward. This is first example. This is second example. So let's see. If you throw a ball upwards, you give it some velocity, and you throw this ball. After some time, it will get to some point and then get returned to back. So when it is going upward, it has covered some distance d, and what I've said that gravity acting on the ball, that work done by gravity on that ball is negative. So let's say find out work. So formula of work is F d cos theta. F is force, and in this case, force is gravity, and gravity is acting downwards. Mg. So force is mg. Displacement. Displacement is upward, and it is d. So there is d. Now velocity, that gravity is downward and displacement is upward. What is the angle between both of them? 180 degree. The force, that is mg, and the displacement, that is upwards, both are in opposite direction. So we can see that angle between mg and displacement d is 180 degree. So we will write cos 180 degree, and it comes to mg into d into cos 180 degree value is minus 1. So it is minus mgd. So we can see that again it is negative work. So this is the concept for the negative work, that when force and displacement is in opposite direction, then work done by that force is negative, and its value comes like this. You can always, if you let's say in any case, if you forget the formula, you can use this basic formula and you can get any of the thing. If you understand the basics, you can get the next thing, and you can always find out it. But yeah, to save our time and do things in exam early and efficiently, you have to learn things. And yeah, basics is always important, and you should learn also, you should remember also. Okay, this is the concept of the negative works. As I said, that negative work means force is reducing the speed. Let's take this example. When this gravity is applying on this ball in downward direction, what happens? At initial phase, there is some v, then v get reduced at some point, and till it reaches the top. At top point, v becomes 0. So what it is doing? Reducing its speed. So this negative work means that speed will get reduced. Not that work is bad. There's nothing like that. If I say there is negative work means work is bad. No, this is physics. We talk about a sign, positive and negative sign, and what it do with the speed. If it is increasing the speed, or if it is decreasing the speed, or if it is nothing doing with the speed of the object. So now next is zero work. Okay. So in zero work, we have studied earlier in this chapter. I have told you one case, this case. See, there is work done zero. So it means that there is zero work done, and you can see the case if force is perpendicular to displacement. Whenever force and displacement are perpendicular to each other, then work done by that force is zero. So we can write when force is perpendicular to displacement, then work done by that force is zero. Okay. So, as I said, that force and displacement are perpendicular to each other. We can take same example. You can see with same example that let's say there is an object, and because of some force, or let's say some velocity, and it is moving to this, and there's a displacement d. And if I told you that find out work done by gravity. So what you can see that work done by gravity, first we have to find the force, and force is what? Mg. The force is mg and d is d. We can write like work is equals to F d cos theta, and F is what? Mg. D, I have taken D. Direction of displacement is this. Direction of force is this. These are perpendicular to each other. Then we write theta, angle between force and displacement, is 90 degree. So we can write 90 degree. MGD cos 90 is 0. So anything multiplied by 0 is 0. So in this case, work is 0. So for this, zero work, force and displacement will be perpendicular to each other. Then we can say that work is zero. Now we can take any real life example when work is zero. When we move in circular path, let's say there is a circular path, and when an object moves in this circular path, then there is centripetal force applying on this. Like when object is here, the centripetal force is here. When object is here, the centripetal force is here. So in this case, the work done is zero. Okay. Now you have to see it very precisely to find out that how work done is zero in this case. Let's say, take it is always centripetal force is always towards the center. So let's say this object is here and it is moving in this direction. Okay, in this case, this force is acting here, and just take little displacement, this little displacement d. Now you can see that this displacement in this direction of displacement, and force direction is this. And when this displacement is tangent to this circle, and you know that tangent to the circle is perpendicular to radius, so, and this force is acting along the radius. So, angle between these is 90 degree. That means this displacement and this force is perpendicular to each other. That's why in case of centripetal force, the work done is zero. This is the real life example. The work done is zero. So in circular motion, work done by centripetal force is zero. So this is it. There is a three things that I've told you: positive work, negative work, and zero work. So if you want to revise it quickly, so you have to just remember three things. One, two, three. Same direction. If force and displacement directions are same, positive work. If opposite direction, negative work. If perpendicular to each other, zero work. Simply you have to remember this, then you can write it according to you. This is the basic concept of it. Nothing big. Okay, now I will move forward with the next topic. Our next topic is work done by gravity. Okay, in this also there are topics divided, but actually the core concept is same in every topic, and I have I have showed you through examples also. There is nothing new in work done by gravity. I have told you through examples. You know all the things. Just it is a new topic. It is written like in different sections so that you understand clearly. Otherwise, there is nothing new. Okay. So, in work done by gravity, there's some cases we can take, like case one is lifting an object upward. Okay. So there, through any ways you can lift an object upward, with your hand or by throwing a ball or putting an object in the lift. You can lift it. There is only the concept that if you are lifting, if the height of the object is increasing, then this concept comes in if you are lifting the object. So what's happened with the work? So I will take the example of throwing a ball. If you throw a ball upwards with v velocity and it goes somewhere there, and there is displacement d, and we have to find out the work done by gravity. So what is force here? Gravity, and direction of gravity is downwards, and if its mass is m, gravitational force value is mg. So F is equals to mg, and displacement is d in this direction. So you can see that direction of displacement is upwards and direction of force is downwards. It is in opposite direction. Now you can, without even solving this, you can at least say that if force and displacement is in opposite direction, the work will comes with negative sign. And now we will solve it, and then you can see. So force is mg, and we can write work is equals to force displacement cos theta. Force is mg, d displacement cos theta. Theta is angle between force and displacement, so it is 180 degree. Cos 180 degree. So mgd, value of cos 180 is -1. Now minus mgd. There is nothing new. I have told you that this is negative signs comes with the different direction of this. But yeah, you should remember this so that you can solve questions very easily, very quickly. whenever there is lifting of any object, if question ask or if you need to find out work done by gravity, you just write minus mgd. You don't have to solve it and take it. If this is asking for work done by gravity, or if you need to find in anywhere, if in the concept of lifting an object upwards, you can use this work directly, you can use it. So that's why it's important to teach it in different topic. But yeah, very basic concept is exactly same. The basics will always be same. So in this case, what gravity is doing? Negative work. Gravity does negative work. But it doesn't mean gravity always does negative work. No. In this case, only gravity is doing negative work. Now, case 2, it is object falling downward. When object is falling downward. So same case, take same case. When this object is going upward, the displacement direction is upward. Now this ball go upward till its velocity becomes 0. Then this ball will come downward. Whenever you throw a ball, this ball will go upward, and after a time it will come back. So I will take now this motion when it is coming downward, as this topic says object falling downward. So when it is coming downward, let's say from here to here, it is coming downward, so displacement is this. And since it is coming downward, the direction of displacement is downward, and the force direction is same, it is still downward. So you can write, you can see here the displacement direction is downward, so I can write it like displacement direction is this, and mg direction is downward, so mg direction is downward. So direction of both displacement and force is same. So what was the case for the same direction? Positive work. So when we find out this, we can see that work will be positive. Okay, now write force is mg and displacement is d. Now we can write work is equals to fd cos theta. F is mg, d, theta is angle between displacement and mg is 0 degree. Both are in same direction, d, mg, 0 degree. There is nothing different. So cos 0, mgd, the value of cos 0 is 1. So now we can write mgd 1. So in this case, work done is positive. So we can write that in this case, work done by the gravity is gravity does positive work. In this case, gravity does positive work. Uh, Now, the very important concept is you can see that in some case gravity is doing negative work. In some case, gravity is doing positive work. So we cannot say that gravity only does negative work or gravity only does positive work. We cannot say that. It doesn't depend on the um, that gravity is since gravity is always in downward direction, it means that gravity always do negative work. No, it doesn't depend on that. It depends on the relative direction, that what is the direction of force and what is the direction of displacement. If both the direction of displacement and force are in same direction, then work is positive. If direction of force and displacement are in opposite direction, then work is negative. So it is very important that work done by gravity depends Okay, this is on change in height. Okay, I will explain this. Not on path. This is also very important, that work done by gravity depends only on change in height, not in on path. What it means, let's take an example. Let's say there is this object and there is force acting on it in this direction. If I pull it in this direction, this object will go along this path, like this. So it has covered some distance horizontally. Um, let's say it's S. Give it some other nomination. Um, some distances and some distance in this direction. Let's say height H. Okay. Now, if we think that what is work done by gravity. So gravity, and let's say in this direction, that object from here to here, it covers some distance A. So its path is this. The displacement of this object is A. But we cannot, it doesn't depend on A. The work done by gravity doesn't depends on A. It depends only on the height, change in height. How I can say that one component of A is this S and another component is H from right angle triangle. If I see that this is A, this is S, and this is H, okay, we can write like A squared is equals to S square plus H square. This is now if I have to find out work done by gravity. Work done by gravity. So what I have to write? F d cos theta. So if I can see that this S, okay, this S displacement and this is mg. What is angle between this? 90 degree. The angle between this force and displacement is 90 degree. So if force and displacement is perpendicular to each other, what is work done? Zero. You, you can see from here, perpendicular, zero work. So in this case, zero work. So because of this, there's no work, there's zero work. Now we will consider this. So in this case, this direction displacement is h, and this direction is mg, and angle between this is 180 degree. Now we can write this becomes zero. So we can now write mg d cos 180 and mg d minus 1 and minus, okay, minus mgd. So you can see that the horizontal direction is doing no work done by gravity in horizontal direction is zero. It only depends on height, not on path. This direction effect becomes zero. That this I have written here, and this you should remember. It will um, help you in solving questions, and it might be asked in theoretical format as well. This is very important. Okay, so these are the theory that I have covered today. Now we will solve some questions. Uh, let's say some question. Let's say there is one question. A force of 6 Newton is applied on an object at an angle of 60 degree with the horizontal. Calculate the work done in moving the object by 2 meter in the horizontal direction. So, when you are solving question, always make diagram. It will reduce your effort and you can see clearly what is happening, and there is a very minimum chance of getting wrong. It will make it easier to understand. Always try to make the diagram. So a force of 6 newton is applied on an object. Just make an object and do whatever question is telling. A force of 6 newton is applied on an object at an angle of 60 degree with the horizontal. Okay, there is this horizontal line and it is making 60 degree with horizontal. 60 degree with horizontal, and this force is applying in this direction. The magnitude of the force is 6 newton. Calculate the work done in moving the object by 2 meter. What is the displacement? 2 meter in the horizontal direction. Okay, we have force, we have angle between displacement and force. Since this is angle is from horizontal and direction of displacement is also horizontal, we have displacement. We can easily find out the work. Work formula is force FD cos theta. You can write FD cos theta. What is force? 6 Newton. What is displacement? 2 meter. Cos, what is angle between displacement and force? 60 degree. So 6 into 2, 12 into cos 60. So value of cos 60 is half. You have to remember the value of cos, sine, and all the trigonometric functions and all. Other you will come across questions when you need it, so you should remember it. And if you guys have any problem with the values, you can ask me. I can give you that. Okay, so this comes to 6. And what is unit of work? Joule. So we will write it joule. You don't have to write a unit in all steps. It will messed up with the digits and numericals make it wrong. So try to write unit at the end of the solving after solving the equation. Okay, so it comes to 6 joule. Okay, next question. A person lifts 5 kg potatoes from the ground floor to a height of 4 meter to bring it to first floor. Calculate the work done. So, what is given? Person lifts 5 kg potatoes from the ground floor to a height 4 meter. Height is given 4 meter to bring it first to the first floor. Calculate the work done. Yeah. So, work done by gravity. Work done by this man. Okay. So, what this man is doing when this man is uh, taking potato from ground floor to first floor, it is working against the gravity. When we go upwards, what we do, we go against the gravity, so we have to exert force at least equal to gravity. That's why the force exerted by this man on the potato is equals to gravity. So force is equals to what is gravity? Mass into g. And what is mass in this case? 5 kg. And g is, you can take 9.8. So it comes to 49. Force is 49 Newton. So we can write work done is equals to force into displacement cos theta. So in this case, mg always apply downwards, and this man is taking this potato to the first floor, that is upwards. So it this man have to exert force upward again, against gravity, so that it will bring it to first floor. So the force that man is applying is F and upwards. So force is upwards and displacement is also what? Upwards. This force and mg is equal, but not the direction is equal. This force and this displacement is there, and the angle between this is 0 degree, because the direction of force and displacement is 0 degree. So the value of F is 49. Displacement, what is the displacement? 4 meter. And cos, the angle between force and displacement, 0 degree. So 49 into 4 into cos, value of cos 0 degree is 1. So we can write 49 into 4 as 196, and unit of work is joule. Always write unit at last, and always write it. Never miss the unit. You have to write the unit. This is the basic thing when we are solving numerical. Okay, that's it for the class. And try to read. I always tell this in the class, that try to read all the theory from the book, so that you understand it well, and try to read this lecture, and also solve the questions that are given in the book. And wherever you get the question and material, try to solve all the things. And yeah, you can ask me if you have any doubt anytime. Okay, that's it for the class.